So this video is going to step you through problem solving methods that we're going to use throughout the course of the year. We're going to pertain them to constant motion to start with. I'll use them on pretty much everything that we do throughout the year, including moving quickly into accelerated motion soon. So what are the steps? So our first step is going to be write down the problem information. So basically that's reading the problem and defining variables and determining what the unknowns are. Second part of it is a label diagram. For one-dimensional problems, maybe not as necessary, but might still be a good idea. But for two-dimensional problems, it's a must so you can keep track of information. For question 3, our formula and working equations. We want to isolate for the appropriate variable before plugging values in. That's what I mean by working equation. You want to make sure that you solve algebraically and isolate that unknown, and then you can go ahead and substitute things in and solve, which is our next step. Substitution, so show me that you plug in the right values based off the given information, and then you solve from there. At the very end, make sure we box our answer with the appropriate units and number of significant figures. So always make sure to go back and double check that so your answer is clear. So for instance, we have a problem here called where it says sonar waves travel at 1400 meters per second in water. How deep is a submarine that returns a ping to a surface ship 0.40 seconds after the waves were emitted, not was. Grammatical check there, but that's okay. So want to write down the problem information first. So the first thing we know is that the velocity is 1400 meters per second for sound in water. We know that the time it takes to get to the back to the surface ship is 0.40 seconds, and what we're trying to solve for is our delta x. How far away is that ship, that submarine? So the next step is draw a label diagram. So we have the water here, and we have our little ship on top of the water, okay, and then we have our submarine down here underneath the water. So what happens in this case is it sends a ping out, sound wave hits the submarine, and then returns back to the surface. So we know the time here is 0.40 seconds, and that the sound wave travels this way at 1400 meters per second, and then it also travels back up at the exact same speed. So there's my quick label diagram. Now our formula working equation. We want to solve for delta x. Okay, so our working equation is our equation that we usually been given is velocity equals displacement over time, delta x over t. We want to actually solve for delta x. So isolating, we do algebraically delta x equals v times t. So then that's our working equation right there, isolated for the variable we want. Then we're going to do substitution. So we have 1400 meters per second times the time of 0.40 seconds. And if we solve for that, that is 560 meters. So then we want that to be our boxed answer with units and sig figs, so we'd box that, we think. However, if we look at our diagram real quick, we're going to find that that 560 meters is the distance to go all the way down to the ship and back. This is where the diagram actually helps. It's not 560 meters to get to where we want to go. That means the sound traveled 560 meters. The actual distance to the ship is going to be half of that displacement. So we're going to go 560 meters cut in half, or 280 meters down. Our quick double check is right number sig figs. 0.40 has 2 sig figs, 1400 has 2 sig figs, 280 has 2 sig figs. We have our units, we're good to go. So that's kind of the basic way we're going to solve problems in here. Not super complicated to start with, but they definitely get more and more advanced as we go along.